Welcome to the second day of RIIAA. We are very excited that you are here in this event with us. Today, to start the day, we are having the keynote talk of Margarita Sordo, who is a senior medical informatician at Harvard Medical School. Her work focuses on the application of adaptive systems to evaluate the impact of determinants of individual health and public health policies. I will leave this space to Margarita. Thank you, Margarita.
Thank you so much, Jennifer, and thank you so much for the invitation. I'm really excited to be here today. Yesterday, I listened to a couple of talks, and also I was in a panel, and they were just wonderful. So congratulations for all the effort that you put into this conference, because it was so far so good. So I'm going to start, my talk today is about challenges in artificial intelligence, but it's going to be from the perspective of healthcare, because that's the area I worked in. However, I believe that, what I'm going to talk about actually applies to every other aspect of our lives and different application fields like finance, economics, you name it. So what are the challenges? We tend to think that it's about data, especially now that we have we can access data from so many different sources, and the amount of data has become available is it's growing pretty much exponentially. However, I think that, well, in addition to data, we could talk about, powerful algorithms. The more data we have, the more computer power we're going to need, the more power is going to be embedded in our algorithms. So the decisions we provide, the outputs we provide should be happening in real time. And this is supported not only, again, by the amount of data that we have available, but also by, computers are really powerful. We have access to cloud computing with all the infrastructure that we need to develop our algorithms. However, I would ask, is that it? Is that all there is? Are these the two only challenges we need to focus? I would say that not quite. From my perspective, what we need and what the challenges encompass is, we need to have responsible AI. And by that, what I mean is, so it's a little bit rephrasing of the title. So what are the challenges of responsible AI? So we need to have, proper methods for data collection. We need to have a governance. We need to know how we're going to manage and curate and share all the data and knowledge and algorithms that we create and we accumulate. We need to have implementation strategies. So we have consistent methodologies for, again, gathering, managing, implementing, deploying, incorporating feedback, and so on. We need to have, also interoperability guidelines so we can share data in a meaningful way. And we need to focus also on integration. If we're going to be developing applications that are going to be ultimately satisfying or fulfilling the needs of end users, we need to be aware of how we're going to integrate those applications in in workflow patterns, so they are not disruptive, but actually provide additional help. Another aspect is we need to focus on bias. We see that bias exists in the real world, and when we develop models that use data from the real world, and then we incorporate that data into our algorithms, and we make decisions as to how we train the algorithms, what we include, what we exclude, we are sometimes unwittingly incorporating this bias into the algorithm. So the output we're going to get, it's going to be biased as well. So we need to be mindful about this. We need to incorporate also explainability. We should be able to understand how the algorithms work, what needs they are fulfilling, what data element they are using, and how the decisions provided by the algorithms reflect those data elements that was going to be happen, changing. If you think of a neural network, how things are going to be changing, the structure in the weights and everything. So that's an impact, and we need to understand that and be able to communicate that to end users. And another very important aspect is, privacy, ethical, and legal issues. We need to be, very responsible as to how we collect, we handle, we curate, we share data. So we preserve the privacy of people, and this is particularly true in healthcare. But again, that this applies to any other realm of the real world. And there are ethical and legal issues that we need to keep into consideration. So what we end up doing is having a methodology that is to develop algorithms that reflect these ethical and legal issues in terms of fairness and legality. So in terms of data collection, we tend to go pretty much practices are inconsistent. We tend to go with ad hoc collection methods, that serve a specific needs of a project. We focus on the project, and then we go, hunting for data. We gather all the data we can, and then we are ready to jump into training our algorithms and get something out of it. So as a result, there are no clear acquisition protocols. There's no documentation as to how collect the data, how that data is going to be revised, cleaned up, aligned, especially if we are using multiple sources. So again, we need to have clear guidelines as to how we follow this process, so they are repeatable. So basically, what I'm talking about is that when we have a project, we need to. The first question we have to ask is, who's going to be, in our data? So that goes to the target population. So to give an example, if we want to focus or we want to implement a tool or an application for predicting the risk of myocardial infarction, that's a heart attack. So who's going to be the target population? So pretty much we're going to be talking about adult people, right? So just by that, we are already removing all children. So it's adults. The next step is what kind of data? What are the properties of those adults that I want to have in order to use that data as input, for training my algorithm? So that becomes, what relevant properties I'm going to be looking for. So, for example, we're going to have demographics, we're going to have age and gender, race probably, and then some information about the clinical state of the patient. Whether they have had the heart attack or not, whether they have high blood pressure, diabetes, and so on. And how's that reflected in the data? So the patient's going to have lab tests reflecting abnormalities in glucose, so that goes to diabetes. We're going to have vital signs measurements that goes to high blood pressure, and so on. So another aspect is what's the time frame, for the data. And by time frame, I don't mean when are we going to get the data, because we're going to say, well, we're getting the data right now. By time frame, I mean from all the data over time, from people, that we have access to, what's going to be our starting point. So if, for example, we have 10-year data, up to now, we can say, okay, I'm going to use those 10 years, completely. So we go from, let's say, 2010 to 2019 or something like that, right? So we define the time frame. Then we need to focus also on the acquisition methods, right? How we're going to extract the data, how we're going to prepare the data, how we're going to clean up the data, and so on. So that all that goes to the why, what's the rationale for the project, and with these, we need to have the input and support of subject matter experts that actually understand, the problem from their perspective, from their field. So in this case, it would be clinicians, physicians that understand in medical terms what's needed, and not necessarily the how. We are looking at satisfying a need of the end user. So we need to have their input. So whatever we do from our technical perspective actually reflects those needs, those concerns, and the end product is, then therefore is more likely to satisfy those needs. Sometimes we tend to go for, quantity over quality, especially now that we have access to tons of data. Sometimes we think, well, yeah, sure, the more the merrier, just bring everything you have and we're going to put that into a very powerful algorithm and we see what we get. And I don't think that's the way to go. There has to be a balance between the quantity and quality. We need high quality data. We need data that we actually understand, that is consistent and that is clear. And then, well, if we have, good quality data, then yes, the more we have, the better. But then just throwing in the kitchen sink, into an algorithm and seeing what we're going to get out doesn't quite work very well, especially when we get to another aspect, when we want to understand what's going on, what variables are relevant, and provide that information or share that information with the subject matter experts, with the users, so we can get some feedback. Another aspect is when we have, complexity in the data. A very simple example is when we tend to put data into buckets because we have an idea that, okay, for example, we're going to get gender, and then immediately we think, okay, well, it's male and female. So we have a binary value, and we already decided that, well, 0 is going to be men, 1 is going to be women, and yeah, this is all fine. But when we start looking at the data, then we realize that, well, first of all, we have missing values, and we need to figure out how we want to treat that. But also, there's more than one, option for gender. So how are we going to handle that? How are we going to? We cannot get, someone that maybe biologically is a woman but doesn't identify as a woman. We cannot decide ourselves that we're going to put that person into, classify as female. So we start getting, that complexity sometimes is disregarded when we start looking at the data. Another example is in terms of ethnicities, race and ethnicities. Normally here in the US, when we look at race we have, white, African American, Hispanic, Latino, Native American, and so on. So in Hispanic, Latino, all the people from Latin America and Spain, probably even Brazilian people, probably even Portuguese people. I don't know how they handle that. It's going to fall in the same big bucket. But if we think carefully, when we start separating, there are regional differences. So think, for example, of someone from Mexico. Yes, it's Hispanic or Latino origin, but think of someone from Argentina, also, Hispanic or Latino origin. But then, the regional differences, Mexico has a very different setup, than Argentina. So those differences in the environment and the genetics of people, from different countries, that's something that we need to keep in mind, even if we are not going to actually, dissect that big bucket into smaller buckets. At least we need to be aware of these issues. Another aspect is lack of training in data collection. We tend to go just for we gather the data, and we don't pay much attention as to how we collect that data. We don't talk to subject matter experts. We don't document all the processes that we follow, the decisions that we make. As a result, this reflects a lack of quality assurance in the processes that the processes don't actually exist, but then the lack of quality is very present, and sometimes this quality, if present, relies on specific people who have the experience, who have been done for a while, and collecting data for a while, and then they understand what's important or what's not important. So again, this has to be written down in as processes and methods, so other people can follow. And by doing that, we can start incorporating consistency in acquisition methods. So in summary, for this first challenge, we need to create clear, consistent, reusable data collection protocols with definitions and policies for not only eliciting the data, gathering the data, filtering, managing, and reusing data across projects. So that's another thing, right? So the next step is, the next challenge focuses on governance. All the decision-making processes across the enterprise have to be structured. I don't know what's happening with my mouse here. Okay, let me see. It should be structured, consistent, explainable. In terms of, if we have structure, then we can start, looking at how the processes work, and then we can start gathering explanations. If we have explanations, and methods that are structured, we start seeing consistency, right? If we have consistency, that means that we can reproduce what we tried the first time. We can, for one project, we can reproduce that same methods, processes in another project and expect the same results. And by this, I'm talking at a higher level, where the processes apply to any project, regardless of the application. If we have explanations, then we have transparency. We are able to present and explain and understand what's going on behind the scenes, so other people can understand and participate, and and see that things actually make sense. And all this has to be fair. We need, like I said at the beginning, we need to keep in mind that some biases can be introduced. That sometimes an algorithm can favor one people over another. So we need to keep this, very, very much in mind. So for this, we're going to have, some guiding principles, in terms of validation, transparency and accountability, ownership. So again, who owns the data? And by owning, I mean who extracted, processed, prepared the data. So that conveys some ownership. That person is or team is responsible for that data and the decisions that were made. And therefore they are accountable if something needs to be revised or improved. And by having full documentation of data and knowledge processes, again, that brings up, surfaces a layer of transparency and consistency that is, really needed. So once we have our guiding principles, it's very important that we write them down and that we remind people every chance we have that those principles exist and that we should follow them. So we maintain a consistency. And this when you design your processes to support, they should be based on the principles, and that we shouldn't go, cutting corners, because then we introduce inconsistencies that later on are going to surface. So when it comes to implementation strategies, another challenge, consistent strategies that rely on a platform to support, standardization of processes. So we can see how, what I've been saying so far, with we need consistency, and in order to have consistency, we need to standardize methods and processes for data and knowledge collection, curation, and as well for tool development. We need to have sustainable management of dependencies, especially when we have silos of data, data from different sources that we either want to integrate in one big data set, or even if we keep them separate, we want to establish dependencies so we know that, the data element from this set here is equivalent to data element from this other set that I have. The same applies to knowledge, and we need to integrate, tools and applications. So far, I think the emphasis or the enthusiasm has been on creating applications that satisfy needs, but those needs are very punctual and applications are very punctual. So I believe that we need to start thinking about building platforms or ecosystems of applications where they can be integrated, and then one application, we have one application here, not only provides an output on itself, but also can communicate and share, and say that internal knowledge, with another application. So we start building things that are more robust and in a way more flexible and could be reused in different contexts. And, what we're going to get out, is probably new insights, new knowledge, that then if we understand the whole process and what we've been doing, those new insights, can be incorporated or fed back into our knowledge. So as we iteate into developing new applications, the first round we're gonna get something, but the second iteration for that application, we hopefully gonna have something that is more robust and that is a little bit better, that provides better answers. Then we get to another challenge with is interoperability. That happens when I want to, I already have my, great data set, but I want to connect to either an application from another institution, or I want to consume data from another institution. It's basically, we want to share things. We want to share what we have, in terms of data and in terms of algorithms. So for this, we need to take advantage of existing standards, not only for validating the structure of our data elements, but also validating the values for those, the valid values for those data elements, and add meaning, to the structure. If we take advantage of, semantic ontologies, then by just pointing to one concept in a reference terminology, we are already providing a definition, that is pretty much universally accepted, as to what that particular data element we are using means. Just to give you an example, if you think about a lab test for cholesterol, there are different types of tests for cholesterol. So you have one in your data set that is fasting cholesterol. So for that, you would go to LOINC, that's a reference terminology for laboratory tests. And you can look at the definition of what fasting means. You can look at what the valid range for those tests. You can look at the units of measure. If you want to incorporate data from another data set, or someone is sharing that with you, well, then you could validate if your test for cholesterol, which is fasting, actually matches the test of cholesterol. If they don't, even though on the surface you are talking about the same thing, your test for cholesterol is fasting, and let's say that their test for cholesterol is non-fasting. So they are not equivalent, and you need to treat them separately. Another aspect, when it goes to interoperability, is we need to have some ETL services if we want to share data, and knowledge, because we need to transform that, as ideally as it is, and we dream of having like a universal data model where the data from any source is going to fit. In reality, that's not the case. So once we have, our data semantically tagged and validated, and then we want to share, and then we can provide transformation methods either for importing data from other sources or exporting our data to other sources, so we can actually share and communicate in terms of data. And then also what the tools and applications can communicate and share, not only in terms of the data, but also in terms of knowledge. So when it comes to integration, that's another important challenge. We need to have a clear understanding. I'm talking about specifically of clinical needs in the context of healthcare, but again, this applies to any other area. So we need to have a clear understanding of the clinical needs and workflows, because we're going to develop applications, and we want to insert them, at the right time, along the workflow. Just to give an example, if we develop an application that makes recommendations for procedures, or let's say a medication order, for a patient that happens to have a particular disease, if we provide that, like later on the workflow, when the physician, as the patient encounter, physician-patient encounter goes on, the clinician is going to be documenting all the information and is already making, decisions here and then, in their head, so they can focus on identifying, prescribing the right medication. If our algorithm, provides information about that medication when they are ready, they are ready to submit the order, well, that doesn't really work. We need to identify, the specific points where if we are inserting here, a tool or an application to provide decision support to physicians, well, it needs to happen here, or something in here, and so on, along the workflow and without disrupting the workflow of clinicians. Another important aspect is that we need to have a clear understanding of algorithms. If in addition to providing an output or a suggestion, the physician needs to know how output was reached, in terms of data values that reflect the clinical state of the patient. Then, where probably if we think of deep learning, that's not going to work for them, because well, you're going to get the answer, but you don't know what happened inside. You don't know how the input values actually produced. You cannot follow the path inside the algorithm because you have a black box. So you don't understand what happened. So you cannot provide, or completely fulfill the need, of physicians. And for this, well, we need to have, well-trained algorithms with enough and diverse and well-selected data, in order to, as we incorporate as much diversity, not only our algorithms are going to be robust, when they get deployed into the real life, but also we're going to be minimizing the possibilities or the impact of having biases embedded in the algorithm. And once we go through the full process and deploy our application, we need to keep a close eye on how the algorithms and applications behave in the real world. Because even though we pay a lot of attention to how we gather the data and we follow all these principles, and we got for the diversity and inclusion of all possible values combinations and so on, that's never going to match what happens in the real world, because then some weird or unusual combinations could happen that we didn't think of or we didn't identify in the training data. So we need to see. And even when the algorithms behave in the way we are expecting, we need to see if they are satisfying the needs of the end users, because it could be a great algorithm, but then it really is not providing any extra information, any extra help to physicians. So maybe there's an opportunity for improving, how either at which point in time we insert our algorithm or how we develop the algorithm. Sorry, I went the other way. And because of this, we need to reevaluate the performance, of our deployed algorithms based on, feedback from users. Because at the end of the day, what we are looking for is creating these tools and applications to benefit end users, to make their lives better, easier, safer. When it comes to bias, it's very important, like I've been saying already, that we understand both data and algorithms. So we are very mindful as to what we select and why and how. And therefore data sets and algorithms must be adequate and carefully selected for the intended purpose. Like I said in the previous slide, if we are required, one of the requirements is to be able to extract explanations as to how a particular algorithm reach a conclusion and provided some output, then a black box algorithm is not really going to work. And we need to identify and review performance and exceptions during training, just to see if everything is going as expected. And even when it goes as expected, we need to question, our definition of what's expected. We need to look at exceptions during training, and then, talk to subject matter experts, the end users who are going to be using our applications, just to gather that contextual information, contextual knowledge that is vital for creating robust applications. Another important aspect, is that we need to distinguish causality from correlation. An example of causality would be a infectious agent, causes a disease, as we well know, even though not everyone becomes very ill. But when we think about correlation, like we have, risk factors that are, present and seem to be and seem to go along with the output, but they just happen to occur at similar times and similar situations. But basically that factor is not really causing the output, right? Or the outcome. So we need just to give an example. We know that salt is closely correlated to the total number of calories we consume. Because tasty food, is better than bland food. So if something is very tasty and nice, well, we want more of it. But we also know that excessive eating, sometimes leads to obesity. Not, there are some lucky ones that can eat whatever and they don't gain weight. But in some cases, we need to be mindful of what we eat, because it could lead to obesity. And we also know that obesity and high sodium consumption, which is salt, contribute to high blood pressure. But do we really know which one is causing that increase in high blood pressure? Does it happen all the time? So a correlation provides, extremely valuable evidence that we need to confirm, as real, and then further explore to see if those correlations are actually causal relationships, that occur in our data and that we have identified. I don't know what's going on with this. Well, when it comes to explainability, another challenge, I think we should be able to provide explanations for why an AI system behaves in a certain way. So that goes to not only understanding the data, but understanding how different algorithms work. Where are the strengths and where are the weaknesses? In which context algorithm number one is better than algorithm number two? What are the pros and cons of using one over the other? So, as the technical, the AI expert, we should be able to understand that, and then explain that, because we need to boost the confidence and the trust, in the accuracy and correctness of the predictions that we expect to get out of the algorithms. However, what is and this is important because we need to ensure that there is accountability, in the output. So if we understand again what's going on and why, then we have transparency. We own the algorithm, so to speak. We own the methods, the training methods we selected, the decisions we made along the way. We own the data that we prepare to serve as input. So then that makes us accountable, in terms of the output that is going to be produced. So when something needs to be improved, end users, can come to us, and then and then see how things can be improved. That's probably a kind of like a after sales service or support. It's not that, well, okay, here's your algorithm, bye. I finished my job. My job was to create the algorithm. I'm done. It's not like that. But then when it comes to explanations, we should be able to provide meaningful explanations that should be targeted, to the audience, to the end users, about the tools and the applications. Again, going to the example of interacting with clinicians. If I implement an algorithm, what I should be able to explain is like, okay, well, I'm using this such and such different information. I have demographics, I have, lab tests, diagnosis, medications, and these reflect the clinical state of the patient, and the algorithm functions in this particular way. So what the output you're going to get is based on these data variables and values reflecting the clinical state. Ideally, like, I don't know if you saw the keynote presentation yesterday by Michaela, I believe, was excellent. She addresses these issues, and I think it was very well explained. So we need to provide these explanations, but they must be targeted, to the end user. Really, a clinician or a physician is not interested in understanding the math, that the differential equations that are going to happen inside, and if, no, they don't care about that. They just want to know how the algorithm works, at some high level, and how the data that is going in, is being used to provide an answer, right? And also explanations have to be timely, like I said earlier, with it in the context of providing an output, that is going to incorporate, something that is inserted in the workflow, and provides an output, but then that happens down the road, so it's not very useful. The same thing happens with explanations. If, going back to the example, if our application recommends a particular medication, let's say medication A over medication B, then the output is going to be medication A, but then we should be able to, at the same time, provide an explanation. Just to give a concrete example, if medication A, is metabolized by the liver, medication B is metabolized by the kidneys. Both medications are used for treating the same disease. But it happens that, the patient has renal problems. So we're going to go with medication A that is metabolized by the liver, because medication B is metabolized by the kidneys, and the kidneys are already somewhat compromised by either a chronic condition or some other things that are going on. So putting that extra burden on the kidneys is not really recommended, unless, there's no other option. So by saying, okay, this is medication A, and this is why, because the patient has information, has some data elements reflecting, problems with kidneys, and medication B is not recommended. So then we are providing the explanation at the moment that we are presenting an option to the clinician, to the end user. So in terms of explanations, they must be clear, specific, right to the point, not getting all over the place, relatable and actionable. Once if we present something saying, back to the example, that medication A is metabolized by the liver, therefore is recommended, then we can actually insert a link to some reference in the literature supporting that option that we are presenting. When it comes to another challenge is when it comes to privacy. We gather data from all over the place, right? We got from patient records, mostly in healthcare, but also from wearables, devices that now measure not only how many steps we walk, but also there are things that you can stick to your skin and then measure your glucose levels and so on. That's personal information that has to be protected. So when we have data from these sources, we need to be very aware and mindful as to what data elements or what information in those patient information we get, can be used to identify the person. And then we should, scrub that out, map it, mask it, whatever. So we protect, the identity and the privacy of the people. Specific examples are, identification numbers, like a medical record number, the credit cards, social security number, but also, factors that are specific to physical, physiological, mental, economic, cultural, or social identity. Because once, for example, you have the zip code, the postal code of in a given record, right? You can incorporate other sources and see what the demographics, even if you don't have, the distribution of the demographics for that particular zip code, even though in the specific data that you have, that's not showing, you have the code. And then by having the code and then connecting that with the, the physical, physiological, mental health, well, you can start drawing connections. So that's all valid as long as you protect the identity, and the information of the person. So therefore, data has to be protected. It has to be de-identified. Should and must be treated. It's confidential, and must be used for legitimate purposes. In the hospitals, when we request data from patient records, we need to fill out like a formulary explaining what we want to, what kind of data we want, and that goes to slide number 1, I believe, or number 2, when I was talking about the who, what, why, and how. All those things need to be specified, and then we can say we're going to be using this data for this particular project. And once we have the data, it's not that, I already have the data, so I'm going to do this other thing on the side. No. If you want to do that other thing, then you need to reapply. So, so you are held accountable, because you are being entrusted with patient data that has to be protected and has to be used for legitimate purposes. And if something unfortunate happens, and there are data breaches, or, we put our data in a memory stick or whatever, and then, whoops, we lost the stick. Well, we need to notify, in this case, not only the hospitals, and then mechanisms for notifying people, all the people that were in that data set. And that's why, all this consistency and processes and methods exist. So here, the accountability is kicking in because something unfortunate happened. So we can go back, trace back, all the people that were included, and then notify them. And there are already, there are laws and mechanisms and recommendations, both in the European Union, specifically with the General Data Protection Regulation, the GDPR. And they cover not only health, but they cover, financial and any kind of personal data. They have, very strict regulations, probably stricter than here, protecting data from people, personal data. Here in the US, specifically for healthcare, we have, HIPAA, that protects health-related data. And we also have the Federal Trade Commission that protects some other aspects of data, personal data. The difference is that, when it comes to the Trade Commission, they make recommendations that are not necessarily followed by all the states here in the US, or they are not followed, completely. So when it comes to ethical and legal issues, we need to be mindful as to how the data we are gathering is going to be used. Was it carefully selected, transformed? Is it protected? That we track it along the way. Think of what it's called, evidence, tracing the evidence along the path. The same thing needs to happen with data. There has to be accountability at all different stages. So again, we maintain, the level of transparency and trust, because we are embracing, consistent methods to make sure that, data are protected. We also need to be aware of, how algorithms are trained and used. If there was a rationale for selecting one algorithm over another, was it fully understood? We just pick one, and we went with that, or we actually look at, all possible algorithms, and then, we gave it a thought, and then selected the one that we thought would be better, for a specific project. Another aspect is who is responsible, not for the results produced by the algorithm, and also the new data that is coming out of using that algorithm, either as knowledge or even as a new data that augments our initial data set. So who is responsible for that? So again, by having, guiding principles in terms of governance, we can answer these questions. We know who, all the people that was involved in the process from when we started, we defined the project, we got the data, we developed the algorithm, and so on. Because then when we get to the legal issues, we need to know, if something happens, who's going to be liable. For example, if we have a self-driving car, and then something happens, and then the car goes crazy and it's involved in an accident. Okay, who's responsible? Who's liable for that? So it goes back not only in legal terms, who's going to be responsible? So I guess that by embracing that responsibility, not as a bad thing, but as a good thing, it would make us more mindful as to, what the activities and the decisions we carry out along the way until we have the final product, not out of scare, but actually as a responsible thing to do. We also need to think about who profits, from a specific AI tool or application. Is it just one individual? Is it a community? Is the access to that tool or application limited to few people, or is open to everyone? Are the benefits derived from that application limited again to just a small number of people, or are they open to all? It's the same thing, with reverse instead of benefit, the potential harms, is this particular algorithm more likely to harm a subgroup of the population, or it's equally, that harm could equally happen. That is kind of a reverse the bias, the thing, but that's also that we also need to consider. These things could happen, and even when we cannot tackle them, we need to be aware of them. And finally, I think even though maybe what I was talking about is just rules, I think that responsible AI is more than making rules. You know? It's about, you know, how we use data, how we use the algorithms, how we design our tools and applications, how we incorporate, you know, regulations and governance principles, not to restrict what we can do, but to ensure, you know, that what we are doing is sound, follows a method, you know, is reproducible, is consistent, and how we can, you know, what methods we put in place so we can protect, you know, the patient data as we are entrusted with, you know, data that is pretty much private. How we go about transparency and explainability. You know, how we help end users understand, you know, what's going on, so we can foster, you know, and gather or gain their trust. How do we justify, you know, one decision over another, you know, so that things we need to consider, you know, how in ethical terms, you know, what are the potential implications of, you know, the algorithm or algorithms that we are embedding in our applications, and what's the socioeconomic impact, you know, on people, who's going to benefit, who's going to be left out, you know, who are the winners, who are the losers. So really what responsible AI is something that we need to focus, so it will benefit, you know, everyone. Thank you so much.
Thank you very much, Margarita. I think you covered the most important problems of applied data science and AI. We run out of time, but I would really like to make some questions. Sorry.
Sure, if you have, you know, quick questions. Otherwise, I don't know if I can show my, you know, there's, you can see my screen. There's my email, and I'll be happy to answer questions.
Yes, but I would like you to answer some 2 questions that I have here. I just can't find them. I found them. And the first one would be, what are your thoughts about the idea that AI algorithms lose power if they gain interpretability? How to deal with the trade-off?
I think the interpretability goes to understanding how the algorithm works. I don't believe that you know, if just increasing it or going for interpretability is going to affect, you know, the power. Maybe you need to start incrementally, you know, like for example, if instead of going, you know, full speed into a deep learning algorithm, maybe you can start with a simplified, you know, regular vanilla neural network, you know, and see how it works, you know. So then when you put things together, then you end up maybe with, you know, what becomes a deep learning is a combination or a collection of simpler networks, you know, that are put together. So that helps understanding what's going on. You know, it's not only, you know, going back to the neural networks, not only understanding that, well, yeah, you're going to have a gradient descent because you are looking to minimize the error and blah, blah, blah. Yeah, we all know that, you know. But the important thing is in the context where that algorithm or that application is going to be applied, then we construct explanations that are meaningful, that make sense, you know, to the end user, and also what to us, because along this process we're going to learn new things. You know, we're going to learn about the context where the algorithm is going to be applied, you know, or the application, you know, going to be used. So I don't think there's a trade-off, you know, like just finding, the right combination and maybe doing it incrementally. And again, yesterday's talk by, I think, Michaela, is that I'm pronouncing her name correctly? She touched on that. So I think it's recorded, people should look at it, because what she actually addresses that. She has a parallel module going on that is, I believe, if I understood correctly, is used as a proxy for explaining the algorithm. So that is actually producing the output. So there are similarities. It's not one thing that is just like, oh, well, over here and the actual algorithm is down here. No, there's an equivalence, but then the one is focused on the explainability, and the other one is focusing on the classification.
Yes, I totally agree that Michaela's work is a great example of how to work with explainability in AI models. The second and last question would be, I think inconsistent data collection is a very important issue in Latin America. This is a very complex problem, but do you have any advice for us to start fixing that?
Well, my advice would be, first, gather what is available, and then instead of kind of reinventing the wheel, look at what you have, and align that data with reference terminologies. I know that it's extra work. Sometimes it's easier to say, "Mama, I'm gonna come up with my own personal standard," because that's the way I feel, more confident about doing things. But looking at, reference terminologies that have been around for years and are actually used, then you have your data that it's all over the place. Well, you can start drawing connections, looking at what's the definition, just a very silly example. I have age in my data set, What does age mean? Well, look at the reference terminologies, because there's something that's going to tell you that age means, the number of years since you were born, right? But because then later you want to distinguish based on age, was it, pediatric population from adult population. So that means you need to draw a line. You're going to have a threshold for that. So again, you can go to reference terminologies and look at what's the definition for pediatric population. So it's up to 19 years old. So, well, that's your threshold. That's your line. So you use that, you draw the line. Yeah, in the process, you're going to lose some things. So you need to reconcile things and say, okay, well, it's 19, but well, I'm going to go with 18. But then you document that decision, because again, down the road, when you train your algorithm, you are done with the project, and then, next week, you are not going to remember, why you put 18 if the definition says 19. So again, document. So it's more work. I get it. It's more fun to get the data, let's try the algorithm and see what happens, and then you start getting something, and then you do some plottings and things, and that's more fun. But it's not consistent. So you have to have a solid platform and a solid methodology that you follow. So initially, it's going to be more work, but it pays, because then later on, that data set that you defined, for your project one, let's say 6 months ago, well, now you can reuse that and add actually extra data that you gather, and it's now consistent.
Yes, totally. Well, thank you very much, Michaela. I would like to invite the attendees to the panels that have already begun. And if you feel like you lose any talk, we are going to keep this recorded so you can listen to the answers of Margarita Sordo later, or to the panelists you missed in some few days. So thank you very much, Margarita.
Thank you. Thank you so much.